Hey folks, good evening everyone. So today we are starting with data structures on focus. So in today's session, we'll be focusing on linked list. So to start with, I'll be very clear. This is completely for beginners and not for someone who is looking for advanced content. So people, if you are looking for to get started with data structures and to get into product-based companies, this is the right way to start here. So to introduce myself, I am Venkatesh. I am the AVP of FACE, and I've been completely into development for almost 10 years. And product development, data structures, and algorithms are one of my core areas. So in today's session, we'll be dealing with linked list. And why do you want to start with linked list, and how to go about from here on would be the concept of this session. So let us get started. So I'll be sharing my presentation now. So if you are getting into a real-time problem, mostly everyone will know about how to use arrays. So in a real time, what is the problem that you are facing with array, and why we are moving to a concept called as data structure? Data structure is very simple, people. It is just rearranging the data. Whatever data you have, just rearrange it and display it. That is going to be your data structure. So now, if you take this real-time problem of an array, if you could see here, we are using a sequential memory here. You are going to use a sequential memory here. This is one sequential memory, this is one sequential memory, and this is one sequential memory. Just for 3 elements, it is very easy to use an array. Imagine for 10,000 elements, 10,000 elements of continuous memory bytes. What will happen in real time? What will happen? So if you could see, and if you take an array, element can be inserted one after another in a continuous way. So if you take 10,000 elements, all the 10,000 elements will be ordered in a linear and sequential manner. So what if I need to insert an element at any position? What if I have to insert an element at the second position? Say, for example, I need to insert an element 2 at the second position. So what should I do? So at this point, what will happen is, like, you have to now shift each and every element of an array one by one. So this is one of the most difficult situation you might face. In the same case, while you delete an element, I need to delete an element from the list of 10,000 elements or an array of 10,000 elements. If I'm deleting a middle position element, what will happen? Once again, I need to I should not have any empty spaces, right? I need to reshift back all the elements so that it forms a contiguous memory. These two are important drawbacks of an array. That is the reason we are moving towards a concept called as linked list. If you could see here, we are moving toward a concept called as linked list. So what is the advantage of linked list? You can, whenever memory space is available, you can store your data in the available memory for use. You can see here 8, 3, and 5. It is not a contiguous memory, but it is in a scattered memory location. Wherever we have a memory space, we are utilizing the memory space so that it does not add any burden to the operating system. You are not putting a burden to the operating system, and since you are not putting any burden, you have another option of referencing the memory from one point to another. You can refer a memory from one point to another. So from 8 you will have a link which is pointing to the next memory location. Again, from 3 you will have a link to which would be pointing to the next memory location. So if we even take 10,000 elements, it is not going to be of contiguous memory. It would be of a scattered memory. Wherever a memory is available, it would be utilizing the memory so that it will not add any burden to the OS. So this is the place where you have to think about the complexity efficiency of the application. How efficient is your application, or how fast it can access your data. So all these perspective comes. See, for example, if you are having 10,000 elements in an array, what happens to search an element? So it is going to be n, and even in linked list it is going to be n elements. But the only factor which is more advantageous here is uh, the OS burden is getting reduced in case of a linked list, but rather in case of an array, you are adding a burden. You are forcing the memory, you are forcing the operating system to give you a continuous memory of 10,000 elements. So this might not happen in real-time application. These set of things might not happen in a real-time application. So this is the advantage of having a linked list over an array. And it also depends on each and every one problem, the problem or the application we take. People, are you going to use an array or you need a linked list? It depends on each and individual application. Now let us go and try to create a linked list. Let us understand how we see. In Java we have linked list, in Python we have, in all the programming languages we have a list. So let us try to understand how a linked list is being created, and let us try to finally solve it in Python. So what I'm going to do here is, like, I'm going to show you how to create a linked list first. So see here, it is a simple representation. If you could see here, this is the head pointer, which points to the first location, first data point. And again, the second, the data along with the address of next location. That is the link, right? So it points to the next data. Again, you have the memory of the third data, and it goes on. So this is how the list is being represented internally in the memory. So now let us go and try to understand in depth how a linked list is being created. So this is the insert at end is nothing but an append operation, people. Append is generally insert at the end. That is, you are inserting the element one after the other. So this is insert at the end, and it is also called as append. So what should we do? So you need to create a memory. You need to allocate a memory. You need to allocate a memory that is consisting of data and address of the next data. Address in the sense where it is located. So you could see 3000 here. So this is what you have to do. First step is you need to allocate a memory, and the second step is, like, you should point to the address. So if you could see, first one is memory allocation, and the second one is the address of new node should be stored in the last pointer of the list. So this is the last pointer of the list. So if you could see here, initially this is the first node. So at the end, you should add this address. Once you create this node, you should add this address here. Again, once you create this node, you should add this address here. So this point, this is actually, we are mentioning it as 0. It is actually null. So see here, so 4050, we are adding this location. So this is how a linked list is created. So this is the general algorithm, people. First, you need to allocate memory for each and every node. Together, we call this as a node. A node in a data structure sense, we will have two fields. One is going to be the data field, and another one is going to be the address field of the next location or next memory location where your data is going to be present. Logically, this is going to be a address field. I mean, the entire thing is going to be a memory field. This is going to be an entire memory field. So there are two fields. One is going to hold your data, and another one is going to hold your address. So now let us get on with the algorithm. step-by-step algorithm implementation, and finally I'll show you how to implement it. So initially I told you, right, there are two things in a node. So initially let us define a class called as node. Define a class called as node. So your node is going to be consist of two things. One is going to be the data part, another one is going to be the next part. So normally your node is going to consist of two parts. One is going to be the data field, another one is going to be the next field. So next will point to the next memory location. So this is together, this is actually called as the node. You can see here. So we have a memory out here. So initially, let me keep this location as 1000. It goes on 1000, 2000, 3000 up to n. So in real time, this memory location will be in the form of hexadecimal addressing. This is going to be an hexadecimal addressing mode. So this one is going to be my head part. So to start with, I have an head. You can see here I have defined a head over here. This is going to be head, and head is going to be null. So it is a none here, which is nothing but null over here. And let us define the address for all these things. Now, you can take the append function, people. Append function is nothing but adding at the end. So I'll take this function and I'll explain what is happening out. So initially we have defined a node. So we have defined a node, and we are passing a data from a main function which is going to add to the data part. So if you could see, this together will form a node, and this part is going to be the data part, and this part is going to be the next part. In this we'll be adding the data whatever we are passing, and this part initially we'll make it as null. Initially we will make it as null. So now once this is done, you will understand how it is working. So let me create a temporary variable. So this temporary variable which I'm going to create here is used for navigation. I need to jump from one memory location to another memory location, people. So I have to jump. So the purpose of temp is used for navigation purpose. The purpose of temp is used for navigation. So initially what happens is, like, when I call the append function. So initially I'll call my append function from the main method. I'll call my append function from the main method. So append of data. So let me consider my data as 10. If I consider my data as 10, let us see here, I'm calling append of data. So your program works and it comes to the append of data part here. So self is similar to this keyword. Self is similar to this keyword. It points to the current object. So what happens? Temp is equal to self of head. So temp initially points to head. What is the data inside it? It is going to be null. So your temp is also null. See here, people, self.head is equal to none. So again, I'm making temp is equal to self.head. So what would be the value of head? So value of head is going to be none. So temp is equal to none initially. New node is equal to node of data. When I say new node, I'm creating a node of data. So node of data, what happens here? So you can see there are two parts. So you have a data part here and you have a next part here, and I'm passing the data as 10. So what will happen here? This part gets executed and I'm assigning 10 to my data part. So I'll be assigning 10 to my data part, and my next node will become none. So next is going to become none now. That is null. So new node dot next is equal to none. This is actually called as the new node. So I can just see here new node. So new node is equal to the data part. I have okay, let me keep it as the data as 2 itself, whatever it is given here in the presentation. I have given it as 10, right? And new node of next is equal to null. See here, new node of next is equal to null here. So these two statements are getting executed. So new node is equal to node of data. Data is nothing but in the presentation it is given as 2. I have taken it as 10. Whichever is convenient, you remember in such a way. So it is 2 here. And new node of next. New node of next is none. So this part is the data part and this part is the next part. So these two statements are running out. Now let me go to this statement. If self dot head, so this is your head part. So self dot head, if it is equal to null, that is if it is equal to none. So the auto, whatever terminologies I have used here, it is all from Python people. So we will be solving using Python. So what I have done here is like I have used Python here. So if it is none, self.head is equal to new node. What is the address of new node? What is the address of new node? It is 5000. So I need to pass my address over here. See here, I need to pass my address over here. It is actually 5000 now. So when I execute this statement, if self.head is equal to none, I need to pass the address of new node which is created. So this is going to be your first node. So first node head will point to the first node. Head is an super pointer which is like a parent pointer which will be pointing to the node which contains the first data. See, in case of a linked list, you should understand that I'll be having a head pointer. This is just a pointer, or this is just a node which is going to be pointing to the first node which consists of the data as well as the next node memory location. So this one is actually the 5000. So now 5000 is pointing to the data part, the node, the complete node. So this is for first node. Once this is executed, it returns back to the main method and it comes back again here. It comes back again here. Now once again check here. So now temp is equal to, again it will point to the cell append function. So temp is equal to self.head. What is the value of head now? What is the value of head now? It is going to be 5000 now. So what would be the value of temp now? So it is going to be 5000. So temp also points to the first node and head also points to the first node. So again, I'm going to create a new node. So let me create a new node. So new node is actually 6000. New node is actually 6000. So again, new node of data is data. So when I execute this line, a node is actually created and data is being passed. So node, the value of data is 3 and new node dot next is equal to none. So new node dot next is equal to none. So now if you look at, while we created 2, initially we created the head pointer which points to 5000. Then we created the first node and it is 2 and this part was empty. Now what I have to do, I need to do, I have a new node which is at 6000. So this is at 5000. I need to push my 6000 into 5000's next part. This is what I need to do now. So to do that, we have the else part here. Take this else part. See here, else while temp of next is not equal to 9. So temp is pointing to the first node. So what is temp of next? So temp of next is 5000's next location. So this is actually temp of next. So this is the temp of next value. If temp of next is not equal to null, is this not equal to null? It is actually null. So this condition fails. Temp of next is equal to new node. What is the value of new node? Which is nothing but 6000. So instead of null, this is going to point to 6000. Understand, people? So while temp of next, temp of, what is the value of temp? It is 5000, which is pointing to your first node. So what is temp of next? Which is null. Initially it was null. So while temp of next is not equal to null, the statement becomes false. So it does not enter inside the while loop. It comes outside and it runs this statement. So temp of next is equal to new node. What is the value of new node? Which is 6000, which goes to temp of next. So now the 6000 is pointing here. So the node which contains 2 comma 6000. So 6000 is to the 6000 is the memory address of the next data. So again, this pointer is going, this location is going to be null. So this is how a node is being created. See here, you can see here 6000 is being added to the memory location. So once again, I'll explain. So initially you have two places. One is going to be the data part, and another one is going to be the next part. So if you consider data part, this together we call it as one node. So this together we call it as one node. So what happens when I call the append function? I pass append of data. I'm going to call append of data. So what happens now when I call append of data? So data, let me consider as 2 as given in the presentation. So append of data. So what will happen here? So let me create a temporary variable. So it initially creates a temporary variable which points to self.head. Initially, while starting, your head does not have any value. So it will be, your temp is going to be null. So, and when I execute this statement, you actually create a node. So one part is going to be the data part, another one is going to be the next part. Your data is going to be 2, and new node dot next is equal to none, which is going to become null. So none. Again, if self dot head is equal to none, while at the start when you create a head, it is going to be none. If self dot head is equal to none, self dot is equal to new node. What is the value of new node? New node is nothing but 5000, right? So it is none. So we replace none by 5000. So now your head points to the first node. Once this is done, you return back to the function. Again, see that this linked list works dynamically. You need to call one by one. Once again, if I have to add an element to the list, I'll be calling the append function. So let me call it over here. I'll be calling append again. So let me consider the data as 3. So again, it comes over here. It calls temp is equal to self dot head. What is the value of head now? Head points to 5000. Your temp is going to become 5000 now, as given here. So new node, again, I'm going to create a node. So new node is equal to node of data. When I execute this statement, again, I create a node with the data part, with the next part. And let me make it as none. This node, let me keep the address as 6000. Now we have created another node. Now what should I do? I should add this 6000 to the 5000's next location. So what I'm doing is, like, if self.head is equal to null, this statement will execute only once for the first time alone. So this will not be valid. It goes to the else part. So while temp.next is not equal to null, temp.next, this points to temp. See, temp is 5000. So what is 5000's next part? This location. If temp.next is not equal to none, it is equal to none. So this is failure. It goes to temp.next is equal to new node. What is the value of new node? It is 6000. So 6000 is being inserted over here. 6000. Now, once this is done, again, you will be returning back to the calling method. That is the main method. Again, let me call append of data of 4. So now let me call append of data of 4. So now what will I do is let me go. Again, your temp points to 5000. Again, I'll be calling append function of 4. 4 is your data. It creates a, this becomes temp is equal to self dot head. Temp is 5000. It does not change at all. Now it does not change. Temp is 5000. So when I execute this new node is equal to node of data, again, I create a node which points to 4, and this is going to become none. Let me call this as 7000. So this is going to be your data part, and this is going to be your next part. So now what should I do? If self.head is equal to none, it is going to be false because head points to 5000. So this statement is false. It comes to else. Now while temp of next not equal to none, temp points to 5000. 5000 of next is not equal to none, which is true. Now temp of next is pointing to 6000. Temp of next is actually 6000. So it becomes true. Temp is equal to temp of next. What is the value of temp of next? Temp of next is 6000, which should go to temp. So temp is equal to temp of next. Now 6000. So temp points to this location. Now temp points to this location. Again, it is a while loop, right? So temp of next, what is 6000 next? It is going to be none. It is true. Temp of x not equal to none, it is actually a false statement. This statement gets false. So again, it jumps back to temp of next is equal to new node. What is the value of new node? It is going to become 7000. This is how a linked list is created. Even in Python linked list or in Java collections, you have linked list, right? All are actually created in a similar way. This is how a linked list append function is being created. So in case if you are using add method in Java, then it is like you can understand that this is how internally the list is being created. And the same case, you whatever you do in Python, this is how a list is being created. But in Java and Python, it is being abstracted. Abstracted in the sense you cannot see what is happening internally. So that is what you can do. Similarly, if you know linked list, only then it will be easy for you to work on with stacks, queues, and trees actually. So now let us go and see the implementation part. I'll show you. It is quite simple, people. The same thing, the same algorithm, whatever we have used here, I'll implement in Python and I'll show you. So let me go to editor. Let me take an editor now. Once again, let me go and take an editor now. You will have I will have an assignment at the end. You can also redo this as a mock. So I'll take in Python GUI. I'll present my entire. So I have taken an Python idle. Hope it is visible for you people. So I'll take a new file. Let me save it as I'm saving it as linked list Python. So initially I need to create a class, right? So let us create a class called as node. So whatever I have given in your algorithm, the same thing let us try to use here. So let me create a class called as node. Once again, I'll increase the font size. Hope it is visible for you people. So let me create a class called as node. So in Python, to define a function, we have to use the def keyword. So underscore underscore init method. It is like a constructor which you are using in Java. So I'll have pass two parameters. In case of Python, you should pass the self, which is nothing but the object referring to the current class actually. So in case of Java, you will be using this, right? So similar to this, in Python, we use self. So we have to use data, and remember your indentation, and Python is an indented language. So I'm using Python 3. So self dot, you have two places, right? One is going to be the data part, another one is going to be the next part. So let me call it as next, or you can also call it as link, or whatever you are comfortable with. So let me call it as none. So let me define another class of linked list. So I need to create a head pointer. So let me call it as an head pointer here. So this is one thing. So it is going to be the self. So self dot make the head as none. So initially what I'm doing here is I'm making the head as none. So let me also add some commands over here. Create a head and make it as none or null. So what I'm doing here is I'm defining a node with data part and the address part. So this is your data part and this is your next part. Here what I did is I created the head, which is the super pointer, which is a parent pointer which points to all other things. So let us write the append function here. So see, tab spaces, don't forget to have a proper tabs indentation or else your program might fail. So I'm going to call the append function, which consists of two parameters. One is going to be the self and another one is going to be the data part of it. So I'm having a temporary variable. So temp initially points to self dot head. So temp is equal to head people. And now I need to create a new node. So new node is equal to node of data. Since you are calling node, this itself refers to self actually. This refers to self object. So you can think that I have passed two data here, two arguments to the init method, and I am passing only one argument here. By when you refer it indirectly, it actually passes two arguments. It passes self comma data. So it refers directly inside it. So you need to pass only the data part. So when it reaches here, it considers this as arguments containing self comma data. So new node, and new node of next should be none. So till here what we have done is we created the temporary pointer. We have initialized the head pointer as null. Now when I call this method, only then the node is being created. So I'll put a here. When you call node of data, the actual memory for node gets allotted. So this is the part where your actual node gets created. So it will have two things. One is going to be your data part and another one is going to be a next part. So now what happens? The data two gets assigned and none is your next value becomes none initially. So this is what you have done. So far you haven't created any link to the head pointer and the node which you have created now. So now is the linking part. So how do you link? So if self dot head is equal to none. If it is none, what should I do? Self dot head is equal to new node, new underscore node. The first node, whatever you have created, I am assigning that memory address to head. So now your head pointer points to the first node, whatever you have created. First node, whatever you have created. So else. So once this is over, it returns back to the main method, people. It returns back to the main method. Again, it comes over here when you call the append function for the second time. So else while temp dot next is equal to none. If it is none, temp is equal to temp dot next. So this is for navigation. So for the first node, it only the if part works. Right from the second node, the else part works. So for the second node, the while will be skipping off and it goes to temp dot next is equal to new node, new underscore node. So you can see here we have created the append function. Let us check whether it is working or not. So to check append function whether it is working or not, let me go and write a method now. So what I'll do, so let me call the main method. I'm using the namespace to call the main method. So underscore main. So let me put a colon here. So let me create a list object. List is equal to linked list of. So I have created our object over here for the list function. So I created an object here. So now a small while loop to run one by one. So let me put an infinite loop, true. I'm going to get an input called as data. Here, this is the point where we are getting input. So let me call int of input. So this is the method used to get input in Python. So input of, I'm converting it to an integer and I'm storing it as data. So let me add only the data which is greater than 0. If data is greater than 0, let me call list.append method. So list.append method of, we need to pass the data part. Whatever inputs you got over here, I'm passing it out here. So else, let me break. So how this loop is going to work? It is an infinite loop, right? So we'll get the input now. Input, let me consider the input as greater than 0. If it is greater than 0, it will go to the append function. If it is less than 0, that is the negative value, then I am going to break the loop. So it works until you give a negative value. So let us see here. Now let us run and check whether this works or not. So let me give some value 10, 20. Once again, none type agent, none type, while temp of next. Once again. Okay, sorry, not equal to none. My bad. This is not equal to none. As I showed you in the algorithm, this is not equal to none. Let me rerun once again. So 10, 20, 30, 40, minus 1. So we don't have any print statement, but the code seems to work fine. So let me write a print method. So let us write a method to print the data. So let me go back to this method. So let me call the method called as different list of self. So what I'm going to do, so let me have a temporary thing. So temp is going to be self dot head, while temp is not equal to none. That is your first node. That is the starting node. If it is not none, I need to print, right? So I'll be printing off. So print temp of data. So temp dot data, temp is equal to temp dot next. So let me call the print method over here. I should be calling directly. So list dot print list. So let me rerun once again. So 1, 2, 3, 4, 5. You can see the data is being displayed here. So our linked list works perfectly. Let me print it in a single line. To print it in a single line, it is very simple. Just put a comma over here. Now once again, let me rerun. Let me close this off. So 1, 2, 3, 4, 5, 6, 7, minus n. You can see the list is being created successfully and it is getting displayed. So this is how you create a linked list in Python. So when you say append, you are able to create a node and add it to the end of the list. So it adds to the end of the list. Append or insert at the beginning. You can call it as append or you can call it as insert at the beginning. So now you created a list. Let us also try to understand how to delete a list. So this to practice the exercise, you can actually go to, let me actually take you to go to, you have a, if you have a Facebook login, or please sign up to faceprep.in. You have lot of questions here to practice out. Go to once you log in, please practice, or if you have to read some articles or related anything related to aptitude, soft skills and technical, you can go and read articles here. So there are a lot of mock tests available in faceprep. Get inside the practice session. I'll show you. So once again, I'll show you from the scratch. So please, if you don't have accounts, please sign up to our faceprep.login. So you can find a number of questions and practice available there for you to practice out. Just log in inside faceprep. If you don't have an account, please create an account. Click on practice. You can see here what are the practice tests available. Now for this, I have created a mock test. Click on the mock test part. You can scroll down to the mock test area, and you can see here linked list insert at the beginning. So linked list, this is an insert at the beginning. Click on take test. So what we did is insert at the end. Whatever we did is insert at the end. This is a special session where you can practice out. See here, time is there. You have 1 hour of time to solve this. So this is going to be a sample input and sample output. So this is going to be insert the value at the beginning of list. So you can choose your language over here. So insert at beginning of list is also quite simple. I'll show you here itself. So let me create class node. So let me define diff underscore underscore, let me underscore. So you have self and the data part. So self dot data is equal to data, and self dot next is equal to none. Please be very careful with your syntax and indentation. So let me create a class called as linked list. So let me initialize the head node. So self dot head is none. So let me put def insert at beginning. So self and data. So new node. So node of data. So insert at the beginning is very similar, people. If I have to see first element is 1, 2, 3, 4. For example, let us consider, let me insert 4 at the top. So again, if I insert uh, 5, then 5 should be at the top of 4. Again, once again, understand what is the question of this. So insert at the beginning of a list. Insert at the beginning of list is like initially if I enter 1, then if I enter 2, 2 should be at the top and 1 should be at the bottom. So the output should be 2 and 1. So that is the way it has to work. So this is the logic for it. I'll also make the screen size much more bigger for you to see. I guess you can see here. So what happens in case of insert at the beginning of list is, I'll go and explain once again. I'll take a slide. This is perfect. So insert, this is at the end, right? So this is at the end. In case if I have to insert at the beginning, what should I do is like I should, this is going to be my head part. So it initially head points to 5000, which is nothing but 2, and initially it is going to be null, right? So again, if I have an element called as 3, then the value of 3 should be at the top position. That is 3 should go over here. That is this head pointer should become 6000 and this 2 should come over here. So this part should be 5000. So this is new node, right? So new node of next is equal to head, and head is equal to new node. So this is going to be the exact thing. So the output should be 3 and 2. If you could see, the output should be 3 and 2. Again, if I insert 1, 2, 3, 4 and 5, then 1 is, then what happens? So initially when I say 1, 2, 3, 4, 5, if this is the input, what will happen? So it is going to be 1. On top of 1, it is going to be 2. And top of 2, it is going to be 3. And top of 4, it is going to be, sorry, on top of 3, it is going to be 4. And top of 4, it is going to be 5. And head will be pointing to the first node, which is 5. So this would be the order. So 5, 4, 3, 2 and 1. So this is what we are doing here. I'll also this is what we have done here. You can actually straight away go and practice out in our platform. This is the place where you can take the mock assessment. You can see here you have the mock assessment part. You can see here I'm just typing it over here. So let me take it out. So let me show you here in this code itself. It would be very easy for me to write it here. So it is very simple. So def insert at beginning. So I passed two things, right? Self and data. So new underscore node is equal to node of data part. and new node dot next position is equal to head. So it is going to be self dot head and self dot head is equal to is going to be new underscore node. That is the node which is created new. That is 2. So head will be pointing to 2 and 2 will be pointing to 1. So let me actually comment this. Let me comment this and let me call list dot insert at beginning of data. So let me run. Let me see if I missed something. Once again, let me close this off. Let me run now. So 1, 2, 3, 4, 5 and minus 1. See here. So on top of 1, 2 is there. On top of 2, 3 is there. On top of 3, 4 is there. On top of 4, 5 is there. So insert at beginning. Insert is at beginning is nothing but push and stack people. If you know insert at beginning of a linked list, then you can easily create a stack operation. So append is nothing but a queue operation. Insert at the end. Queue first in first out, one after the other. So append is nothing but a enqueue in queue. Insert at beginning is nothing but push and stack. If you know linked list once, you can do a lot of operations. And imagine whatever Facebook, the way the post gets displayed, it is nothing but a stack operation. Your messenger, your whatsapp is nothing but a stack operation. And your friends list, you can see, right? Friends list, student name list, it is going to be a list. All you can see a list view in Amazon app. All the products are getting displayed in a list order. The way of arranging the data, you can see, you can understand, right? All the data is being stored in the database, and when you retrieve it in Facebook, you are showing in such a way that it is very easy for the user to see it or to view it. So that is how it works. So the way of arranging the data is very important to make the application much more user effective and very, very efficient. So you can see we have done two operations. Insert at beginning is very easily done. This is actually insert at beginning. I'll also put comment over here for your understanding. So it is going to be insert at beginning of a linked list, which is nothing but push operation in stack. So your append is nothing but insert at the end of the linked list, that is NQ in Q. Very, very simple, people. If you understand, you should visualize how the memory is being allocated internally. Only then you'll be able to understand how the entire data structure works. So if you are able to understand how the memory is being allocated internally for every application, when you call a list, what is happening out, when an array is happening, what is happening inside the machine, you should understand your system completely, the way the memory gets allocated. If you have that visualization you should visualize it in your memory mind, so that you are able to write a clean code, or you are able to write a very efficient application or code. So this is one thing. So the last thing is like deleting the application. So I have done how to create an element, or how to add at the beginning, how to add at the end, and how to delete at the end. Now I'll tell you the logic for deleting at the end. You have in case of linked list, you can insert an element at any position too. So you can try out those things. And you can also try out delete at first position, delete at last position, and delete at some position in the middle, any position in the middle. So all these things you can do. And there are various questions that are being asked in the product companies. You can go and check out various company questions within the Facebook platform. If you don't have an account, please log in here, go here. You will also get the solution. Once you submit it, you can visualize the solution. Once you finally submit the code, you can go and check out what would be the answer. For example, I have done I have done only the half part. So if you complete the entire code, you can see the output here. You can see the solution in all the three languages, people. You have solution for C++, you have solution for Java, you have solution for Python. Whatever you are comfortable with, please go and you can check out the solution in the Facebook platform itself. After taking out the mock test, you have a lot of questions to practice. You can practice each and every question. So let me go and finish off where I left. So delete at the end. So delete at the beginning is there, delete at position is there, and delete at the end is there. So this I'm not going to show you how the code is being actually done. I'll tell you the logic alone. So with the deletion part, today's webinar session will come to an end. This is going to be a series of webinars. Exactly on Thursdays, you can expect IT product company webinars on data structures, and moving forward, it will be also on algorithms. So to start with, we have started on linked list. Next, we will intimate you when the webinar will happen for stacks. So this is purely for beginners who don't have a complete understanding in the data structure concept. Can please attend. Please also refer your juniors to attend this webinar so that they might get an understanding on all these concepts. And this is the start, people. If you do well in data structures and algorithms, you can easily crack out in product-based companies, and you can get into dream and super dream companies. If I say about dream, it is the companies which give you package more than 5 lakhs, and super dream is more than 10 lakhs. All these companies' major focus would be on data structures. So do not compromise with the low salary or getting into one. Don't think of you can just if I get a job, I'll be happy and satisfied. No, you are capable of doing much more than that. Try and push yourself so that you get into a dream job. And imagine if you are getting 70 or 1 lakh in your hand per month. Imagine how your life would be. That should be your target. So let me actually finish it off. So delete at the end. The process is very simple, people. So what I'm going to do is, like, I'll be taking this as the head pointer. So this is going to be the temporary pointer, and initially a temporary pointer will be there. So let me create a, you can see here, your head will be pointing to the first node. What I should do is, like, I'll be having a temporary pointer which will navigate until I reach this position. So you'll have a temporary pointer which will navigate to the position till I meet the second last node. Second last node is this node. Is if this node's next value is null, I should move my temporary pointer till here. Then what I should do, I should disconnect this position. That is, I will make this position as null. Then I will free this space, free this memory. This is what I have to do. So this navigation part is quite very important. So see here, the address of the second last node should be stored as null. Address of second last node. This is the second last. This is last, and this is the second last. And what you have to do, make this as null. And what you have to do, you have to free your memory, people. So this is what you have to do in case of linked list, delete at the end. So I guess it is a two-step process. If you don't mind, I'll also type the code if you want. So it is a very simple thing. So give me 1 second. I'll just type it in the existing thing itself. Let me put. So def delete at end. So let me put the self part. So head, I'm taking, this is actually a temporary pointer. Head is equal to self dot. This is a pointer. This is actually a temporary memory. So If your head is already none, what will happen? If you don't have any data at all, then your head is none actually. If it is none, what you should do, you need to return none alone. If it is already none, what you'll do, it is actually there is no data at all, right? So if your head dot next, that is if there is only one node alone, if you are having only one node, then you make the head as none. So let me make the head as none, then return none. Now let me put the let me take a temporary variable similar to head. So if let me take temp as head. So now while temp dot next, that is the third node, people. If you could see here, I am pointing temp dot next of next. Temp dot next of next is here, this position. This is the temp of next dot next. So this is the position. So if temp of next dot next, so if it is not null, while of temp of next dot next is true, temp equal to temp dot next. So you could see here what I have done. So temp is equal to temp dot next. So that is this position. So temp comes over to this position. So this is now temp. Again, it is a while loop, right? So while temp dot next, if it is again true, this position it will not be true. So what will happen? So again, temp dot next is 4050. So again, temp will come over to this position. See the loop here, see the loop over here, while temp dot next of next. So temp dot next is temp dot next. So again, if you see, I will have this position, temp dot next. So initially it would be, this position will be 4050, right? So if I have, I'll move my temp to this position. Once I move again, while temp dot next is null, this position is null. So while loop will not work, I should come out of the while loop. So I'll come out of the while loop. I'll make the next position as none. So then after that, I'll be returning my head position. Head is the starting position. So let me also call the list dot deleted beginning, right? So what I have kept here, deleted end, list dot deleted end. So list dot deleted end, and again, sorry, it is going to be list. So list dot so let me put deletion. Different, sorry. So list dot, let me call the print list again. So let us run now. So 50, 40, 30, 20, 10, -1. So you can see here, right? One element is being deleted. So deletion at the end happens. So 50, 40, 10, there's like on top of 50, you have 40. So insert at the beginning, right? We have called insert at the beginning. So if you could see, the program works beautifully here. So this is how the deletion works, people. So today we have seen how deletion works, how to display your list, how to insert at the beginning of a list, and how to delete at the end. Delete at the end of list is what operation? Whether it is going to be NQ or DQ operation. Imagine what happens. So delete at the end of list is what operation? Whether it is going to be NQ or DQ operation. Imagine what happens. So delete at the end of list is what operation? Whether it is going to be NQ or DQ operation. Imagine what happens. So delete at the end of list is what operation? Whether it is going to be NQ or DQ operation. Imagine what happens. So deleted beginning and deleted end is actually going to be a, it is going to be similar to pop and DQ. So you can identify which one is this. So with this, our webinar is going to end, people. And you have face prep where you have WhatsApp groups. You can log into our Facebook WhatsApp group, and you can find out a lot of options here. You can get bites on face prep, placement prep. You will get lot of inputs on how to prepare for the companies, and how to get how to strengthen yourself, and you will get what are the companies which are coming out, what is their exact pattern. All these things you can get the update on face prep WhatsApp chat. And you will have a lot of quizzes coming up on a regular basis. You can go through all these things. Please sign into face prep. Will have a lot of articles, free videos on career guidance. You will have a lot of company specific questions which will help you to prepare and scale yourself in the company aspect. And these kind of webinars might happen on a regular basis. Not only this, a webinar will happen for aptitude, soft skills, and product based companies. Specific company questions will be discussed in the upcoming webinar series. Please follow us on Instagram, and please follow us on YouTube, so that you have lots and lots of videos and lots of inputs on Instagram too. Our Instagram page is instagram.com/faceprep, and similar in YouTube, go to YouTube and go to faceprep and subscribers. With this, our session is coming to an end. In the next webinar series, we will be looking into the stack concepts. Thanks a lot, people. Thanks for being patient, and thanks for being here. All the best, folks. Thank you.